Hello, number 6, terminal velocity. Now you've all probably heard the term terminal velocity before. There was even a movie called Terminal Velocity quite a few years ago, starring Charlie Sheen, and it was all about skydiving and murder and mystery, and it's not the fall that kills you. Not a very good movie, but you'll see why I introduced that, because we're going to use the skydiving as pretty much an example of terminal velocity and our understanding of terminal velocity. So what do we mean by terminal velocity? Well, it's when the upward force of air resistance is equal to the downward force of gravity and an object has reached its terminal velocity. So what it's saying is, when you have a terminal velocity, you don't accelerate anymore. When an object is first released or dropped, it accelerates due to gravity, and air resistance is proportional to the velocity. So when it's getting faster and faster, the air resistance is increasing and increasing, and you can see that, or you could experience that. Try sticking your head outside of a car travelling at 10 kilometres an hour, and you get a little bit of air resistance. Do it at 100 kilometres an hour, you get a lot more air resistance. And so air resistance is a force, and it's a force acting up. So when an object first drops, it accelerates due to gravity, but as it gets faster and faster, the rate of acceleration decreases, because gravity is not the only force acting on it. And eventually the two balance each other out, the force of gravity and the force of air resistance, and you can only go at a constant velocity because there's no acceleration. And that's its maximum falling velocity. Now also it varies depending on the size and shape of the object. So something like an arrow has a small amount of air resistance and therefore reaches a large terminal velocity, whereas something like a piece of paper or a feather has a large amount of air resistance and therefore reaches a lower terminal velocity. Now, skydiving, we mentioned that before. Let's go through some of the examples. These are some guys doing it. It's a pretty cool sport. Never done it, but a lot of people do. They jump out of planes, and you can see here that, or you saw in the other slide as well, these guys have spread themselves out, and so they're trying to have as much air resistance as possible. Whereas these guys want to catch up with these guys, so they make themselves streamlined. They tuck their arms in and they point their heads down, and so they will have a different terminal velocity to these guys, and so they will fall down and catch up, and then when they catch up they actually spread themselves out so that they have a matching terminal velocity. And part of the skill of skydiving is practicing everybody having the same terminal velocity and being able to control that terminal velocity, because you want to be able to do these shapes and things and stuff. So how does it work? Well, this is a skydiver that's just jumped out of the plane. You have your weight force, and that's down. You have a little bit of air resistance, and so the difference between these two, it means that there's still, if we do head to tail, there's this amount of force, and that force will cause an acceleration. And so this skydiver will keep accelerating, getting faster and faster, but as they get faster and faster, this arrow will get bigger and bigger, and consequently this arrow will get smaller and smaller, and therefore the acceleration will get smaller and smaller until they reach this point here, where there are the weight force, which doesn't change because you don't gain or lose weight as you're skydiving, and gravity doesn't turn on and off. The resistance force is equal to the weight force. These two cancel out, so there's no force causing an acceleration, so you reach terminal velocity. Hope that makes sense. So there's a couple of videos on the OneNote for you to watch just about skydiving. It's pretty cool. There's one there, there's a world record attempt where something like 400 or something skydivers all pile out of these planes and try and make up a shape. And it's pretty cool. Whilst you're watching that, again, I want you to be thinking about some physics. How are they doing it? What's the physics involved? And how's that applicable to what I'm learning right now? It's not just about being entertained. And indoor skydiving, an interesting one, where you have big fans and people can go in and do indoor skydiving, and it's pretty cool what they get up to in that as well. Now, the world record for skydiving, it was set by Joseph Kittinger in the US Air Force. Excuse me. He jumped from a balloon at 31.3 kilometres altitude, which is on the edge of space, really, on the edge of our atmosphere in space. And so he jumped out and he reached a velocity which was pretty fast of 988 kilometres per hour, broke the speed of sound. He was doing this to test the validity of high altitude jumps at a time when the NASA space program or lunar program was just starting, and so he was looking at what would happen if astronauts jumped out. Plus there was a lot of high altitude planes and things flying around at that time, and so they wanted ways to see if they could parachute. His parachute jump lasted 4 minutes and 37 seconds, and there's a video on the OneNote which is pretty cool about that. Space diving is in the future, apparently, and that's because there's commercial companies going up and starting to launch rockets into space, taking cargoes and tourists, space tourists. The idea is that excuse me, these rockets could actually open up and someone could jump out, and if you're in the right sort of suit, it'd have to be pressurized. It would have to have heating and cooling, because you would actually be cool right here, but as soon as you start getting friction, you'd warm up. You'd have to have automatic parachute systems and all sorts of gears, but people would pay good money to jump out of a spacecraft and to space dive. And so people are developing these suits right now, and the idea is, like this is a diagram that shows there's a mountain, there's where planes fly usually, there's Kittinger's record there, weather balloons go up to 50 kilometres, and these guys want to jump from up above 85 kilometres and fall down, which is pretty cool. Now, there is a guy at the moment trying to break Kittinger's record, and it's what's his name? He's a German guy. Sorry, I can't remember. But it's the Red Bull Stratos project, and he will probably jump. He's already done 2 jumps, and he's got up to about 27 kilometres, I think, was the last jump he did. And the next jump he's going to do is he's going to try and break the record. He did the first 2 jumps because he's actually got Joe Kittinger as a consultant, and he insisted that they actually work their way up gradually to breaking the record, because people have actually died trying to do high altitude jumps. All you need is something to go wrong with your suits, and you either lose consciousness, you could spin out of control and get giddy and lose consciousness. All sorts of things can happen. Anyway, on the OneNote there's a few videos, and there's also a video on wingsuits. And wingsuits are where you've got big flaps of fabric, and people are swooping down, skydiving and then swooping down and trying. The idea is eventually someone will be able to jump out of a plane using a wingsuit and actually land on the Earth without using a parachute, just by swooping down. Some people are going to attempt to do that fairly soon, I think. So let's go back to actually the physics that we need to know, and let's just look at what we've been trying to say. And we'll use a rock in this example. We drop a rock, it's got a weight force. That weight will cause it to accelerate downwards, so its velocity will increase. As it gets faster, the air resistance will increase, and so now we can see that we've got 5 newtons of air resistance and 10 newtons of weight force, so we've only got 5 newtons causing an acceleration. So we have a less acceleration. Then at terminal velocity we would reach 10 newtons of air resistance, so this body would keep falling at whatever velocity it reached. And there's our parachutist. Now, people get confused about what happens when the parachute opens, and so when you're skydiving you reach a terminal velocity, and that terminal velocity when you've got your arms and your legs stuck out, is quite high. But as soon as you open your parachute, you have a completely new air resistance, and so you reach a new terminal velocity. And hopefully, with the parachute open, your terminal velocity is sufficiently low that when you hit the ground, you don't break anything. But you do, the force, your weight force and your drag force remain equal. And that sometimes confuses students as to how you can have a skydiver. Let's draw a skydiver over here. Okay, there he is. Okay, they would have a weight force here exactly the same, and the drag force or the friction force would be exactly the same as the parachutist. I sometimes call F air resist, alright, or F drag is good. Now these situations, these forces are identical, but the two have very different terminal velocities, and that's because of how they got to this situation. Is very different. And if we actually remove this, it might be instructive for me to actually, let's see if we can do this. Let's make a black screen. Let's draw a velocity time graph. So this would be velocity, this would be time for a skydiver. So we have our skydiver. Okay, they jump out of the plane and they're falling. Okay, and they're pretty happy. Yep. So what happens? Alright, you jump out of the plane, you start accelerating, alright, due to gravity. So it should be a straight line, and that slope should be 9.8 meters per second. But as the air resistance increases, your acceleration decreases. So the slope changes, because remember on a velocity time graph, the slope is the acceleration. And eventually you'll reach a terminal velocity. So this here would be terminal velocity. Okay, and then you drift, you do your skydiving, okay, and then you think, oh, I'm getting close to the earth, I better open my parachute. So what happens now when you open your parachute? All of a sudden you go a rapid deceleration. So you have a braking. That's that big jerk that you feel when the parachute opens. And so very rapidly though, because the parachute is a great big thing, it opens, you very rapidly, so you're over here, let's draw you over here, you've got your parachute, okay, it's got a hole in it to stabilize it. So now you've reached a new terminal velocity very quickly, and that will be your terminal velocity there, and so you drift down happily until you reach the ground and you get very close to a sheep. Okay, and then you hit the ground, bang, and that would be the velocity time graph for a skydive. How's that? Pretty cool. Alright, let's go back. Let's see if I can get my screen back. Let's see, this should be alright. There we go. And so what are some of the terminal velocities of objects? Clearly, if you're aerodynamic, you fall at a great velocity, and that's what they're saying here, like a shot, skydiver, cricket ball, tennis ball, ping pong ball, not that fast, so it slows down, got more air resistance than its weight force. Insect, parachutist, so increase the air resistance and the weight force, and you have a lower terminal velocity. So in the next video, we'll have a quick look at what friction is all about. See ya.